So now we got a complex number. Now we have two notations of complex numbers. The one you've been doing earlier is known as Cartesian form. Why it's known as Cartesian form? Because we can plot it on the graph. We said like, oh, a plus bi or j, a plus bi. How do we actually plot that one on a graph? When we plot that on the graph, it gives you a kind of visual representation, a graphical method. How do we plot it on the graph? On the graph, we have two axes. The first axis is here. This one is the imaginary axis. Yep. And this one is known as a real axis. So the x-axis is known as the real axis and the y-axis is known as imaginary axis. Let's say I got a number. I want to plot a complex number, and the complex number is z equals 2 plus 3i. So what I'm going to do is I will move 2 on this side, 1. Let's imagine this is 1, this is 2. 2 on this side, yeah, because that's my a, the real number. And it's a plus 3, so I will move 3 up. 1, 2, 3. Yeah, so that's where the number is going to be. Yeah. Complex numbers are vector quantity. They are not scalar. So to plot that one, I can join these things in a very straight line like that. Yeah. And that is a vector. I can also find out this angle as well, and I will show you how I can find the angle by using SOHCAHTOA, and there is another way. So I will show you that one as well. Any questions so far? No. I'm just going to rubbing it. I go to the next slide. Now let's say we got a multiple complex number, 2 plus 3i minus 3 plus 2i minus 3 minus 2i, 2 minus 5i, 6, and I. Yeah, this is actually 1i. Yeah, when there is nothing, it's a 1. So how do we plot that one? The first one, let's have a look at the first one, 2 plus 3i. What is 2 plus 3i? So you move 1, 2 here, because this is 1, this is 2. So you go 1, 2, 3, 4, 5, 6. Yeah. So you move 2 here and 3 up because of positive. And that is 2 plus 3i. If you're looking at minus 3, so for minus 3, you have to go on the minus axis. This is positive real axis. This one is a negative real axis. You have to go towards a negative side. So you go on the negative 3, 1, 2, 3, negative 3, and then 2 positive here. So this is that one. Yeah. Now we done the second bit here. Now if you want to do the third one, minus 3, minus 2, minus 3, minus 2. So you go minus 3, which is here on this side, real 1, 2, 3, and the minus 2 is down. Yeah. So that's where it is going to be. Then we got 2 minus 5j. The next one, 2 minus 5j. So 2 is going to be 1, 2 here, and minus 5j, 1, 2, 3, 4, 5. So 2 minus 5j is going to be on this side. Now, if you are plotting just the number 6, which is just real, it's not imaginary, it's just a real number. So it shouldn't raise anything on the imaginary side, I or j, up or down. It's not going to move up or down. So this is what you do. You do 6. 1, 2, 3, 4, 5, 6. Here you go. That's just a real number. Yeah. Because this 6 is actually, in fact, this 6 is 6 plus 0i. Yeah. So we're just going to move 0 on that side. And similar to that one, this j is actually 0 plus 1j or I. Let's call it I. Yeah. So if I want to plot that one, it's here. I'm not going to move anywhere along the real axis, imaginary axis, I just go up, yeah, and that's it. Remember, I is equal j. They are both same thing, yeah. This is engineering notation. This is mathematical notation, yeah. So, okay. Any questions so far? Whichever you like. Yeah, in your calculator, it's an I. I prefer an I. Yeah, easier. I will give you a question in I. Yeah, okay. Now, rectangular form and a polar form of a complex number. The Cartesian form is known as a rectangular form. For example, 2 plus 7i. Let me just, let's say 2 plus 7i, yeah, minus 3 plus 2i, or anything like that. This is known as rectangular form. It's also known as Cartesian form. Yeah, rectangular form or Cartesian form. What is a polar form? Cartesian, because you can plot it on a Cartesian graph. This graph is known as Cartesian graph. Yeah, x and y. The polar form. What is a polar form of a complex number? Polar form of a complex number is written in this form: r angle theta. R, this sign is not the less than or greater than sign. This sign is an angle sign, angle theta. What does R mean? This is an angle. It's not like this sign. Yeah, this is that and that is straight. Yeah, so it's the angle sign. R angle theta. What does R mean? What does theta mean? Now let's go to the next page. Now imagine we got a complex number. Imagine we got a complex number. Complex number is here, let's say it's a plus bi. Then what I do with the complex number, I just join the complex number with here. Yeah, that's it. Let's say this was my complex number. Let's say it's 2 plus 3i. Yeah, that was my complex number. I'm just going to call my complex number as z. Okay, now I want you to find out the r. What is r actually? R is the magnitude of this green line. This is known as the r. Yeah. And what is the theta? Theta is a Greek letter we use which represent the angle, the direction. So theta represent the direction and r represent the magnitude. Yeah. So r is the magnitude and theta give you the direction. Yep. Any questions so far? How do we find out? How do you find out the r, and how do we find out the theta? I will show you with an example. Now, the angle, the direction is also known as is that one? Argument. Yeah. So that's another terminology we use for an angle. Theta, direction, yeah, or it's also known as argument. The question might be convert into complex number. Yeah, convert in Cartesian complex into polar complex, polar form. What's the argument? What's the magnitude? Yep. So I will show you an example and we go through that example and we do one question as well. Okay. Now, before I, that's it, that's better. Okay, let's try. Let's say I got a complex number, z, and z is a complex number a plus bi. I want to find out, I want to convert that into a polar form. So convert into polar form. Yeah? And the polar form, I need to write it like r angle theta. How do I find the r? How do I find the angle? Okay, so to find the magnitude, this is what I'm going to do. To find the magnitude r, The formula is square root a square plus a b square. It's better to put a brackets because sometimes the numbers are negative. So it's better to put the brackets because if you put brackets, you will never go wrong. And that is going to give you the r. This is the magnitude. Now I need to find out the theta. How do I find out the theta? Theta, the formula is tan inverse b over a. That's the value. Yeah. You have to copy the sign with a b as well. If that's a positive b, you need to write the positive. If that was a negative b, you need to write the negative. Yeah. Okay. That's how it works. Example. How do we work out? Let's have a look. Let's say we got a number. Let's use red color this time. And I want to convert this number. Should we go on the next page maybe? Yeah. Let's say I got a number. Z is 2 plus 3i. And I want to write in a polar form, like something like r angle theta. Okay. To do that one, first I need to find the r. I don't know what r is, but before that, I know this is a and this is a b. Yeah. Okay. So what I'm going to do is I have the formula for the r. R is 2 square plus a 3 square and square root. And that will give me the value of the r. So now we got the value of the r as 3.6. Always write at least 2 decimal places. Yeah. So 3.6, that's the value of the r. Let's say this time I'm writing 1 decimal place. So I write 3.6 and then an angle. Now I don't know what theta is, so let's find out the theta. Theta has an equation which is tan inverse b over a. Now if I have a look, the b is 3 and the a is 2. 3 over 2. Okay, so if you can please put that in calculator, get an answer. 56.3. Yep. Okay. Now, so that value is 56.3. Yep. Okay. So this is how we have converted a Cartesian form into polar form. If I want to plot this one, this is how it's going to look like. 3.6. Actually, let's do it that way. 2 plus 3i. So what I'm going to do is 1, 2, I do 2 and 3. 1, 2, 3. That's how it's going to be. Imagine I'm drawing to the scale. Now, if I measure this thing, this is an r. This r is going to be 3.6. And if I measure this angle is going to be 56.3. Now, the angle is 56.3 and the value of r is 3.6. Yeah. What 3.6? We don't have any unit. It's just a magnitude. Yeah. So that's how it, if that's a force, 3.6 Newton. If that's a current, that's a 3.6 amp. If that's a voltage, obviously 3.6 volt. So that's how we do that one. Any questions so far?